Oh, yeah, I have literally been waiting the entire course to make this video. It's one of my favorite all-time links between concepts in mathematics, and that is we're going to go over why the Fundamental Theorem of Calculus, the FTOC, makes sense. In other words, why is it that when we antidifferentiate a function and then plug in an upper bound into that function and subtract out the lower bound plugged into that antiderivative, why does that give us the area between a to b of the original function and the x-axis? Why? Let's look at that. Now, do you have to know this in your class? You don't have to know it. But in my opinion, you have to know this. It's so cool. Let's go. So recall, it's very simple, that distance equals rate times time, or technically even displacement is equal to the rate, in this case the velocity, times time. And what I've given you here is a graph of velocity. That's your rate, your y values. And then your time are like your change in x values here. So when we find the area of this entire thing right here, what we're doing is we're finding rate times time. Well, as a definite integral, we know that adding up all those tiny rectangles can be symbolized by, in this case, it'd be the definite integral from a to b of v of t dt. So we know that represents the sum of lots and lots of rectangles, and we know that that equals the displacement. Okay, so hold that as fact, that that is displacement and it is the area from a to b. Okay, on to the next page here. Since displacement is equal to that, which we know it's equal to the area, we know that, then, well, hold on a second. Isn't that equal to, and I have it right here, the ending position, right? So that would be where you end minus where you start? It is. So that is often S of B, where S is the position, minus S of A. In other words, your ending position minus your starting position gives you your displacement. But hang on a second. We just said on the last page, right, and we just confirmed that the area, which is the definite integral, is displacement. And displacement is S of B minus S of A. Wait, whoa. Isn't the integral of v of t the velocity? Isn't that position? It is. So that means that the integral from a to b of v of t indeed is equal to S of B minus S of A. Or in other words, the velocity, which we know is the derivative, right, of some function f from a to b, would be equal to the function that comes before it, evaluated at the upper bound minus the function evaluated at the lower bound. That is the fundamental theorem of calculus explained with physics. Mic drop. Peace.